In this video, we will be doing a longer proof involving an isosceles triangle and perpendicularity. You can see it's much longer than you might be used to. It just takes several times through and you'll get it. Just a lot more steps. So we're going to go straight to the proof here. Proof is here. We're going to write it out on the diagram. We'll be using different colors for different portions of the proof. Triangle ETQ is isosceles with base EQ given. Angle ERW is congruent to angle QYW. Angle ERW right here is congruent to angle QYW over here. WR is congruent to WY given WR is congruent to WY. These two lines will deal with the isosceles triangle. Angle E is congruent to angle Q, definition of isosceles triangle. Angle E is congruent to angle Q right over here. ET is congruent to QT. So we have here ET on this side is congruent to QT on that side, both definition of isosceles triangle. Triangle ERW is congruent to triangle QYW, AAS. You might be thinking it's got to be SSS, SAS, or ASA. The easiest way to think of it, if these two angles are congruent to these two angles, then the third angle over here must also be congruent, which would give us ASA, but you can say AAS. From there, we're going to start with this line in green, starting with CPCTC. So angle EWR is congruent to angle QWY, CPCTC. Corresponding parts of congruent triangles are congruent. Angle EWR is congruent to angle QWY over there. Then ER is congruent to QY, CPCTC again. ER is congruent to QY. RT is congruent to YT, subtraction. If we subtract congruent segments from congruent segments, the results are congruent. Next, WT is congruent to WT, reflexive property. So that is congruent to itself. And you'll notice we have two triangles here that are congruent, SSS. So triangle WRT is congruent to triangle WYT, SSS. SSS on the diagram. We're going to switch to red now for the next portion of the proof. Angle RWT is congruent to angle YWT, CPCTC. Angle RWT right here is congruent to angle YWT right there. From there, angle EWT is congruent to angle QWT. Addition of congruent angles with congruent angles gives congruent angles. This angle here, angle EWT, and this angle here, angle QWT, are congruent. If angles are congruent and supplementary, then they are right angles. We've shown that these two angles are congruent, and then EWQ forms a right angle. So these two angles are also supplementary. So we will take off the congruent markings and put on right angle markings. From there, EQ is perpendicular to WT. If lines form right angles, then they are perpendicular. So EQ and WT form right angles, therefore they are perpendicular. Last note on this problem, it's much longer than you're probably used to, but it can be done. This is a problem that you just have to do a bunch of times before you can get it.